Hello and welcome back to AP Pre-Calculus. We've made it to Unit 3. Today's lesson is 3.1, Periodic Phenomenon. A periodic relationship between two variables occurs when the output values demonstrate a repeating pattern over successive equal length intervals. The period of a periodic function is the length of the x values that it takes to complete a full cycle. Here we have a graph. For example 1, the function f is periodic with a period of 4. What does that mean? Well, it starts here at 1, completes, it gets back down to 1, and starts a new graph of the exact same thing. How long did it take to get from start to where we started a new one? That would be 4. So that's why they're saying the period is 4. From -1 to 3 is 4. So they want us to draw 2 additional periods. So I know that I need to end here at 11 and then here at 15. And I could just do that with each of these. I know that I have to have one up top here at 9 and again at 10. And then I move over 4 from there. So I'm at 13 and 14. All I did was move these points over here. See how they moved 4 to get to these points? I moved all of these points 4 that way, and then 4 that way again, and then we can just complete the next 2 periods. Okay? So here in example 2, they gave us a graph, and they want us to know what is the least possible value for the period of g. So we need to pick a starting point, and it's the easiest way to do this is to pick a maximum or a minimum. So we have a couple options here. We could go from here and follow along until we got back. So I got back to that point, but I want to get back to that point and go down. So we go over here, and that would give us a period of 5 units. You could have done the same thing from the low point, gone up, over, back down. If you start from that point again, you go up and over and back down. So that's the period. That was from 1 to 6, which would also give you a period of 5 units. Okay? All right, let's look at example 3. So using the function g and the period found in example 2, we want to find the following values. And notice these are x values because they're inside the parentheses. We don't go out that far. And we don't want to have to keep drawing this over and over again. So we're going to take one of our periods there, the actual graph. I'm going to highlight it in blue. So that's the period from 0 to 5, right? And every place on this graph, my y values will be somewhere in there, right? Because it just repeats over and over again now. So if I can get this number down to a number between 0 and 5 using my period, I'll know what the value of g of 14 is. So all I got to do is keep going back 5 or forward 5 until I get to a number between 0 and 5. So I could subtract 5 and I get 9. Well, that didn't make it. And subtract 5 again and I get g of 4. So now if I come over here and I go to 4 and go up, well, now I know what my y value is. My y value is 7. Look at B, g of 72. Good Lord, we got it. That's way out there. We definitely don't want to draw that. So I got to keep subtracting 5 and 5 and 5 until I get down into a number between 0 and 5. And this one becomes g of 2. So we come over here, go to 2, go up. That looks like a 6. Now the last one's a little bit different because I got to go forward to get there. So now I'm going to be adding 5. So I need to add 4 5s. I need to add 20 to 17. I'm going to end up getting g of 3. And when I do g of 3, I get 7. All right, example 4 is just like the last one. It's just now we don't have a graph, we have a table, but we're going to do it the same way. We have our input values up here, right? And we know that it's got a period of 5. So we know that 1 is -2, which means 6 would be -2, 11 would be -2, so on and so forth. So we need to get these input values over here into this range. I need to get a 1, 3, 4, 7. I don't know the other numbers, but I know 1, 3, 4, and 7. So if I add 5 to this input value, that puts me at 3. And what is h of 3? 0. Okay. What about b? Well, 6 is in between there, but that doesn't help me. So I need to go back 5, and I end up at -2. Check out C. This is a composite. We just did that in a couple lessons ago. So I can't do anything with the outside yet, but we can work on the inside. H of 9 is too big, so I'm going to subtract 5, and now I have h of 4. Well, I know what h of 4 is. H of 4 is 3. So I'm going to rewrite that as 3. And now I can look for the input of 3, and what is my output? I get 0. All right, so this one looks weird, but let's go ahead and just kind of substitute numbers in for k, because it says k has to be an integer, so let's put in a 1. If I put a 1 right here, I end up getting 2, right? If I substitute a 1 in for that k, I'm going to get h of 2, right? Which seems like it would be all right, but I don't have a 2 up there. So let's add 5 again, and I get h of 7. Well, 7's up there, so I know that this is 2, right? So think about this. If I put a 2 in for k, I'd get 7. I'd be right there already, right? If I put a 3 in for k, I'd be at 12, and I'd have to go back 5, and I'd get back to 7. So that's how you could do something like that. This number here has to match our period, or we're kind of in trouble trying to do it with this small number set table that we have going on up there. So it's useful to have notation to model this phenomena. A periodic function starts with a basic pattern and translates the pattern repeatedly over its domain. As a result, we could consider this periodic function a horizontal translation of itself. Meaning if I just grabbed the function and slid it left or right, I could make it to where it gets right back on top of each other. Even though I've moved the points that my fingers are holding on to, it would end up being the same. So that is what this is saying. So in example 4, the period of h was 5, meaning that we could translate the graph h horizontally 5 units and end up with the same graph. So we could rewrite the function like this. Does that have to be a minus? Do we have to translate it to the right 5? Nope, that could be a plus. We could have moved it to the left 5, and we'd still be on top of each other, okay? So let's look at example 5 here. The graph of f is periodic with a domain of all real numbers. 2 full periods of f are shown. Find all input values of f that yield the output of 1. Looking at this graph, let's highlight one completion of the graph. So this would be what the graph looks like, and if I slid that left or right, it'd be on top of each other over and over again, and I'm looking for all the times I'm going to have this. Well, I have it there, and then I added 4 to get here, so it makes sense if I added 4 more, I'd get here, and that would be 10, right? But couldn't I subtract 4 going this way and get over here like to -2 and have another? So how are we going to show that all of these points, right? So we need to write down all of the x values where we get 1. Well, our first one is at 2. And then we're going to go every 4, right? So plus 4. So how can I say that I'm going to do this over and over and over again? We give it a variable, and normally we give it a variable of k, right? And because that's a variable, that takes care of the subtracting 4 too, because that k could be -1, it could be -2, it could be -3. So this would be all of the different places in the graph where my y value would have a value of 1. Notice on this page it says AP Exam FRQ3 task model. So we know what the 4 free response questions are going to be like. We don't know the exact questions, but we know what they're going to be like, which gives us a big advantage on taking this test. So we know that FRQ3 is going to look something like this, okay? So we're going to spend some time doing a lot of these, because if we can get these FRQs down, we're in good position to pass this test. Let's read example 6 here. The figure shows a large clock mounted onto a vertical wall. The clock has an 8-inch long moving minute. So I know that from here to here is 8 inches, okay? And we want to mark things on our, if we have the ability, pencil and paper, we mark things down to help us get it right, okay? The center of the clock is 120 inches directly above the floor. So now I know from here, the center of the clock is in the middle there, right? I know that that's 120.
Completed cycle. How long would it take to get to the 6? 15 minutes, right? Make sense? All right. And so how high, before I even do this other part, how high could I possibly get on my clock? 128. That would be its max, yeah? Well, what would be its minimum? 112, right? And so that's exactly what it's going to do. And it's going to do the same thing over and
All right, let's see if we can get some numbers on these axes, okay? So I'm going to deal with the y-axis first. That is the height off the ground the tip of the minute hand is. So at its highest point, right here, how high is it off the ground? And we already talked about that. We said it was 128 inches. Well, what about its low point down here? Well, I'd subtract 8 instead of adding 8, so that would be 112 inches. And the midline is 120 because the middle of the clock is 120 inches off the ground. The x-axis is the how much time it takes to get to these different points. Well, I know that a good place to start is 0 because they told me t equals 0 here. And where am I at? I'm at the highest point. So right here is 0 minutes. And how far did we say how long did we say it was going to take to get back to the top? We said it was 30 minutes. Which means to get down to the bottom, doesn't it make sense that it would take 15 minutes? And then here you could put 7.5 and 22.5. And now we can label our points. So F would be 0, 128. G would be 7.5, 120. J would be, what is that, 15, 112. K, back to, let's see, 22.5, back to the center line, 120. And last but not least, P is 30, 128. Okay? Part B of FRQ3 is going to look something like this. Refer to the graph of H in part A. The t-coordinate of G is T1. So this point right here is T1. So let's put a little T1 next to it. So I got T sub 1. All right? And J is T sub 2. So T sub 2. On the interval from T1 to T2, so for the x values from 7.5 to 15, which of the following is true about H? Is H positive? Meaning, is the y value positive? Well, yeah, the y value is positive because I can look at the y values. They're right there. So I'm going to cross out C and D because it says H is negative, all right? H, when it's written like that, is your y value. So is it increasing or decreasing? Are we going up or going down? Well, from T1 to T2, the graph is going down. So my answer is B. And last but not least, part 2 of B says, describe how the rate of change, the slope, is changing over the interval. So what is the slope doing? If you can't really tell by the slope, you could look at the concavity. It is concave up, which means it has to have an increasing rate of change. So how are we going to write this? Because we have to be very specific in the FRQs. So we want to write this the right way. So follow what I'm doing, and you kind of got to memorize how this goes. So what we're going to write is H is concave up. Therefore, the AROC, the average rate of change, is increasing. And that will get you the point.